So hopefully everyone enjoyed sleeping in a little bit this morning. It was a nice treat. Today we're going to expand our knowledge on simplifying radicals. So again, today is 3/18/2014, and we're going to look at simplifying radicals, and we want to take without the root sign. And we talked a little bit about this, I think it was last week. Just to review, we had like the square root of 10. And we said, remember, square root is really to the second power. This is 10 to the 1 power. So we can rewrite this 10 to the half, okay? Or if I have the square root of 9, I could rewrite that square as a number times itself, 9.5. And we sort of looked at this a little bit on our calculators. If we bring up the square root of 9, which hopefully you know is 3, but on our calculators we can do second square root and 3. Oops, that was supposed to be 9, sorry. 9, we get the answer of 3. Or I can raise 9 to the 1/2, because it's 9 to the first power to the second root, and again I get the same answer here of 3. Okay, so if I had, let's say, the cube root of, let's just say, 16 x squared y to the third, I could rewrite that as 16, now this is to the 1 power, so I would say 1/3 x, that's to the second power, third root, so that goes 2/3, and then y, third power, third root, 3/3. Okay, so this top number is your exponent, and the bottom number in the fraction is your root that you're using. And looking at this one, we can simplify this last one because we know 3/3 is 1. And you can also know that the cube root of 3 to the third power is just y. So I would rewrite this 16 to the third power, and then we would say x to the 2/3 power, and then y, just y, or y to the 1. Okay, so one more example here. Let's say I have something to the 4th root. Let's say I had, again, let's go with 16 x to the 4th, y to the 5th. Okay, so this would be 16 to the 4th power, and actually if I do that on my calculator, I'd find out it was 2 times 2 times 2 times 2. This is x, 4th exponent, 4th root, and y to the 5th exponent, 4th root. So again, hopefully we know, and if you don't know, again, we can go to our calculator here, and remember I showed you we want the 4th root, and then we go to math and we choose the root button with the x, because we're choosing what we want that x to be. I want this x to be the 4th root, and I put in 16 here, and it tells me that that root is 2. So then we would have 16 to the 4th is 2, 4/4 is 1, or x to the 1, or just x, and then the y would be remain 5/4. Okay, so using this knowledge, we want to simplify our square roots a little differently. Okay, so let's look at a couple examples. If I just look at this first one, it's just a square root, so I like to put a little 2 there, so I remind myself it's to the 2 power. I'm going to bring up my calculator and see if 2/16 is a perfect square. So I'm going to do square root of 2/16. And I find out that it's not a perfect square because this is not a whole number. Okay, so then I got to think about what will go into 2/16. I want to find perfect squares that go into 2/16. So I know if I add these numbers I get 9. So I'm wondering if 9, since 9 is a perfect square, if it'll go into 2/16. And I find that 9 times 24 equals 2/16. So I can use that to simplify here. So I know the square root of 9 times the square root of 24 gives me 2/16, because 9 times 24 is 2/16. This is a perfect square, So I'm going to bring my 3 up here. Here I know I can do square root of 4 times the square root of 6 is 24. This here is a perfect square. The square root of 4 is 2, so I can bring that out. And then the square root of 6, that's not a perfect square. And then I still have this v in here. So now to simplify that, I'm going to do my math here. So I know 3 times 2 is 6. And then I can change this to, I know this is the second root, and these both have exponents of 1. So I can change this 6 to the half, v to the half, because it's 1 over 2 and 1 over 2. Or if it wants you to leave it this way, I could leave it as 6 square root of 6v. It just depends on what the question is asking you. Okay, so let's look at this one now. This one is to the 4th root. Okay, so again, I want to see if there's a perfect answer for the 4th root of 81. So I'm going to bring up my calculator. I want the 4th root of 81. So I'm going to bring up my 81. And I find out that it doesn't seem right. 36 is a 4th root. 36 times 36 times 36. That doesn't make sense. I didn't do something right. So let's try that again. Let's do the 4th. I don't think I hit the math right. I will need to go down to the 4th root here, which is your mystery root, and then let's put in 81. There we go. So the 4th root of 81 is 3. So I can go ahead and write that as 3. And then this is to the 1 power, so that's going to be x to the 1/4, y to the 4 over 4, and z to the 5 over 4. And I can simplify this one. So I'll have 3x to the 1/4, y, z to the 5/4. And that's how I simplify this using fractions. Okay. So let's do one more example here. Looking at this one here, again, I want to see if there is a nice cube root of 512. So again, I'm going to go, I think I have it here. Yep, 4 is cube root. So I'm going to put in that, and then I'm going to put in 512, sorry. And then I find out that 8 times itself 3 times. So that is a perfect cube. So this is going to give me the cube root of 512 is 8. Then I want to do my exponents. Oops. So it's m, exponent 3, root 3, so that's 3 over 3. N, 6 over 3. And P, 7 over 3. Then I'm going to simplify. 3 over 3 is 1, so it's just m to the 1. 6 over 3 is 2, so it's m squared. And then P is just going to be 7/3. There's no fixing that. So that's my final answer. So I'd like for you to try this one and this one on your own, and we'll work on it some more tomorrow. Have a great night.